how's it going? Vasco here from the Angular University. Thank you for enrolling in my course. Let's get started. We are here at the official TypeScript website. In this course we are going to build an application and we're going to use the work environment that you will typically find in your everyday programming life as a professional software developer. You will install Node on NPM and learn all the tools that you will need in a real project. But before diving into that, and we will do an extended introduction later, we are going to get a feeling immediately of what the TypeScript language feels like. For that, here in the official website of the TypeScript language, we have here a menu entry called Playground. If you click into that, you will see something like this. So this is an in-browser editor where you can try the language TypeScript on your left-hand side, and you can see the output in plain JavaScript on the right-hand side. The fact that their main editor is structured like this already gives us a hint of what is TypeScript and how should we use it. It's an improved version of JavaScript with, like its name says, type safety, and we're going to see already in this initial demo, what are the benefits of that. Let's say that we have a couple of variables here. We have the variable DC Comics and we have the variable Marvel. So as you can see, on the left hand side I have TypeScript and on the right hand side JavaScript, and they are exactly identical. So you could take a JavaScript program and pass it through the compiler of TypeScript and it would work without any modifications. You might have to set a couple of compiler flags for that to happen. We're going to cover that in this course. What I want you to take away from here is that it's an improved version of JavaScript and it compiles down to JavaScript. So let's say that these two variables that we have defined here, notice that they are in capital letters. We would probably want to make them constants. There is no way to declare a constant in plain JavaScript. But take a look here. If instead of making DC Comics a var, I declare it as a const, this is working. It's compiling down to a var on the right hand side. But here, if I try to modify DC Comics, and notice that the auto-completion is working out of the box. This is something that you don't have in plain JavaScript, or you have it in a limited way. This autocompletion has the same power of languages like Java, C-, etc. It just works, and it works all the time. And it's really helpful to build our program. So if we hit here DC Comics and we try to reassign it to something, take a look. Immediately we get here an error, and let's see the error. Left hand side of assignment cannot be a constant. So as you can see on the right hand side, we are still compiling down to plain JavaScript, and this would actually work if you would run it in the browser. But at compile time, we have detected an error right before we even run the code. This is one of the main advantages of TypeScript. Helpful messages that help us to write our program. Also the autocompletion. Let's see a little bit more. Let's create here a variable called editor, and we are going to assign it to DC Comics, again using autocompletion. Now we are going to add here an if statement, and we are going to add here implicitly a block using the curly braces. We are going to say that if the editor is equal to DC Comics, then we are going to do here something inside the block. We are going to define here a var, and we are going to call it Superman, and we are going to assign it to an object. So the object will have a name, which will be Superman, and it will have a property editor, which we are going to assign to editor as well. So notice here the repetition, editor, editor, and notice that var is inside the block. So if we would log this out to the console and take a look, the standard APIs of the browser, like console, are available for autocompletion as well. This includes set timeout or any other standard browser API that you might think. You will have autocompletion working out of the box. So we are going to print out here to the screen hero inside the block, and we are going to add here a colon, and we are going to print out Superman. And notice Superman is available here for autocompletion, and take a look. In front of the word Superman, which is the name of the variable, we have something that looks like a type definition. But how can this be? We did not define any type in this program. Well, this type is inferred for us, and we're going to see what the consequences are. And now one would expect that because this variable is inside a block, we would expect that it's not visible here outside the block. But also notice we don't get any error, and TypeScript will warn us if there is an error that the compiler is aware of. So this looks like valid code. Let's run it here using the run button. This will open a separate window. You will need to inspect the page and you will need to go here to the console of your DevTools. So what we have here two logging statements. One is hero inside the block, which is the Superman object. And we have here a second logging statement, hero outside the block, which is the same Superman object. So going back to our playground, we can see here that although this variable is defined inside a block, this is not a block scoped variable. It's also visible here. So this is one of the problems with plain JavaScript. There are no block scoped variables. The variables take the context of the function on which they are in. So in this case, how can TypeScript help us to catch this error? If instead of declaring Superman as a var, we declare it using the let keyword, we will now get here an error. Let's see what the error is. Cannot find name Superman. So declaring the variable with let instead of var made it a block scoped variable. And take a look. What does the code here look like? It's the same code as before. So the addition of let did not change anything into the generated JavaScript of our program, but we get a compile time error. This means that if in the browser we only run JavaScript that is the result of a valid compilation, we would not run into block scope issues. Let's see another thing that we have here. We have here Superman, and take a look. If I hover it, I have here the Superman definition, name and editor. What does this mean? If we try to the Superman variable to add here another property, let's say that the name of the property is creation date and we are going to assign it the value 1938. Take a look, we get here an error. Property creation date does not exist on type, and then we have the definition of the type with two variables only. So what happened here is, even though we did not use any annotation for defining the type of the Superman object, the compiler has inspected the program, has determined that this is an object with two properties, and it assumed that this object can only have those two properties and it cannot have other properties. So it implicitly created a type on the fly and assigned it to the Superman object. So now we get here an error. This might not be what we want. In typical JavaScript, we would be able to do this. We can always bypass the type checking by using any. And we're going to learn any in detail in a couple of lessons in the future. But this is just to say we can still write something that is very close to plain JavaScript if we really want to. But other than that, the type system is systematically helping us out to write our program. With this, we have an idea of the different features of the TypeScript language and how it helps us to write better programs. We have seen autocompletion in action, type inference, and those are some of the main features of the language. We're going to dive deep into many other features in the following sections. Right now, let's just give a quick high-level overview of the structure of the course and then straight into setting up your development environment. So without further ado, let's get started learning TypeScript. Welcome everyone to the complete TypeScript course. Let's get the ball rolling straight away. Let's give a quick overview of the couple of first few sections that we are going to go over. First, we are going to set up your computer. We are going to install Node and NPM. We are going to install an IDE. We are going to be using WebStorm. We are going to install the TypeScript compiler and learn a couple of advantages of using TypeScript. Next, we are going to approach TypeScript as a better JavaScript. We are going to see what are the features of the ES6 version of the JavaScript language that are available on TypeScript today. We are going to cover that. Next, we are going to dive deep into the biggest feature of TypeScript, its type system. We are going to cover the features of the type system in depth. And that will be the initial introduction to the language. From there, with that basic set of concepts, we are going to dive deep into building an application straight away. So, a couple of sections of introduction of language features, then straight into the application. Once we have built a significant part of the application, we are going to go back to the drawing board and present a few more features: generics, object-oriented classes, and decorators. With those in place, we will be able to use the Angular 2 framework. We're going to build a small Angular 2 client that queries the REST API. And we're going to enhance the REST API with some custom types. We're going to share some code between the backend and the frontend. So, without further ado, let's get started. The first thing is to set up your computer. Let's start installing Node and NPM. Welcome everyone! Let's get started with the course. I really advise you to install Git in your machine. You have a couple of advantages. You won't be needing it to the course, but if you do install it, you will get a very convenient shell to interact with your operating system called Git Bash. You don't need administrative rights to install it in your machine, unless that you want to install the integration with Windows Explorer. It's very convenient to jump to different checkpoints in the course. So let's say that you want to jump to the beginning of section 2 or to the beginning of section 5. That will be possible by installing Git. So it's a good thing to do, install Git first. But this is optional. Now what we really need to install in our machine is the latest version of Node.js. We will be using it both as a small development application server, but we will also actually be running a REST API on it, so we really need Node and NPM installed in our machine. For that, we head over to the nodejs.org website and we download the latest version of Node.js. If you want detailed installation instructions of how to install Node.js, you can head over to the github.com/Angular University page. I will load it here. So here is the Angular University GitHub page, and you head over to the complete TypeScript course repository. In here, if you scroll down, you have a list of curated videos. These are videos on YouTube of how to install Node and NPM for each of the free operating systems. So please watch the video that corresponds to your operating system and have Node and NPM installed. Having Node and NPM working correctly in your machine is really essential because the TypeScript compiler is actually a Node program, the version that we are about to use. So getting these two programs, Node and NPM, installed is very important if you are trying things along as you watch the course. But if by some reason, for example, you are watching the course on mobile, on a tablet, the course will still make perfect sense without these steps. So, without further ado, let's now set up our IDE. We're about to use WebStorm. Before even installing our IDE, let's start by installing the code of the course and see how we are going to organize ourselves to get you the best possible experience taking this course. Please go over to the github.com/Angular-University page and you should see here all the repositories of the Angular University. Here in the Find the Repository input box, you should type TypeScript, and this is going to filter down the repositories until you see here the complete TypeScript course. You click into it and you're going to get to the finished content of the course. So this means that what you have here is a REST API that is built in TypeScript and an Angular 2 client that is querying it. So this is the finished product of the course. What we're going to do here is we are going to start from an empty folder. We will not base ourselves in this repository to start the course, but It will be useful for you during the course to have a fully running version so that you can refer back to it. So what we're going to do is, right from the beginning, we're going to clone this repository, or we are going to download it as a zip file. In this case, let's download it as a zip file, and what we're going to do is we're going to head over to the terminal of our computer or to the Windows Explorer, and we're going to create a folder in our computer where we are going to store all the contents of the course. So in this case, I have unzipped the contents of the complete TypeScript course repository into a folder with the same name. What we're going to do now is we are going to install the code in your computer. This will serve several different purposes. You are going to test your installation of Node and NPM to make sure that everything is correct from the beginning. You should be able to install the application in your computer, not run it at this moment because you don't have yet a database installed and it's trying to do queries to a database. This repository will also allow you, if installed with Git clone, it will allow you to jump to different points of the course. If you want to jump straight to section 3 or section 4, it's possible if we install it with Git. But I'm going to show you that in a further lesson further in the course, because I want to get you going as soon as possible. Next, we're going to install the IDE and we are going to start from an empty folder. So let's get going. To check your Node version, type node -v. So in our case, we are using 6.9.0. Now, as you can see, we have here a lot of files, one of them being the package.json. This is the file that defines the dependencies of the project. So what we're going to do here is we're going to use npm and we're going to install all the dependencies using npm install. After a while, you should get a message similar to this one in your console, and at this point, in case that you are following along the course by coding along, this needs to work at this point. If it doesn't, please copy the full stack trace of the error that you are receiving and paste it in the Q&A section or in the comments, and also add the Node and npm version that you are running. Because if you cannot install the dependencies in your computer, you will not be able to go further in the course. You will be able to do the first few sections if you install TypeScript globally, but you will not be able to build the REST API, which is the core of this course. So let me know if you run into any issues. Also, please specify your operating system and its version. Having said that, you might be following along the course on mobile, on your tablet, and not on a desktop. If that is the case, please don't worry, because the course is made to make perfect sense even if you don't code along. So without further ado, let's install your IDE. Next, what we need to do is we need to download WebStorm. So if we head over to jetbrains.com/WebStorm, we have here the download page of the WebStorm JavaScript IDE. If we hit download, we are going to download a trial version of WebStorm. So this is the most stable version of WebStorm that you will find. If you want to try out the latest features of WebStorm, you can also search for the WebStorm Early Access Program, and this gives you a new version of WebStorm that is not yet released but contains maybe a lot more features if you want to try them out. In this course, I will be using the stable version of WebStorm. Once we have WebStorm downloaded, we are going to open it and we are going to find a screen similar to this one saying "Welcome to WebStorm." We're going to click open and we're going to navigate to the folder where our code was unzipped. In this case, we are going to open the folder at this location, and this is what the opened project in WebStorm will look like. If you hit Alt F12, you are going to open the terminal that we will be using a lot in this course. Now, before doing anything else, we're going to set up TypeScript inside the IDE. So for that, what we're going to do is we're going to first install TypeScript. So we head over to the command line and we confirm which version of Node we have installed. To do so, we head over to the command line and we type node-v. So this shows that we are running node 6.9.0. Now, let's install TypeScript globally. To begin with, later we are going to learn how to install it locally to the project and what are the advantages of it. Right now, we are simply going to install it globally by using npm install -g TypeScript. Remember, as usual, you might have to throw in here in the beginning a sudo if you are in Mac or Linux. So I will just go ahead and do that and install TypeScript globally. This should take a moment, but very quickly you should have installed your TypeScript executable that we will be using in the first few sections of the course. To confirm that the TypeScript compiler is installed correctly, you can type tsc-v and you should see here some version of the TypeScript 2 compiler. So in this case, at the moment of recording, we have 2.0.3. Now, in order to ensure you the best experience possible, you should, at this stage, before doing anything else, configure WebStorm to use the same version of the TypeScript compiler as you will be using from the command line. This is to make sure that you don't get different error messages in the command line and in the IDE, which would be rather confusing. So you find out where your TypeScript executable is. So in this case, I have used the which command in a Mac, which would also work if you are using git bash in Windows. So you copy this path that we will be needing, and we are going to head over here to the WebStorm settings. So preferences, we are going to set up TypeScript here. So first, we should use the node interpreter. We should use also the version 6.9.0 that we are using from the command line. So this is to avoid discrepancies between the WebStorm environment and the command line environment. So here we will switch from version 6.3.1 to the version 6.9.0 that we are also using from the command line. And we are going to set up a custom version of TypeScript. We are going to point WebStorm to the same version that we are using from the command line. So we paste here the path to the TSC executable, but we are not going to click OK at this point. We are going to delete here a couple of top level directories and we are going to open the 6.9.0 folder. So here what we are going to do is we are going to open lib and we're going to drill down to node modules. We're going to find here the TypeScript folder, and here we have a lib directory. So this is the one that we should select. We click OK. So you should have something like the directory where your Node.js is, lib, node modules, TypeScript, lib. And you will see here that this is the TypeScript lib directory. So this custom directory should point to the TypeScript lib directory where a couple of files are found. So this is the correct one. We're going to click OK, and you have here a custom version. So currently WebStorm is using the custom version of TypeScript that we just pointed it to. Now we are going to click enable the TypeScript compiler, and we're going to see in a moment why this is necessary. For the moment, we will not use a tsconfig.json. So let's click apply and OK. At this stage, you should now see here at the bottom a TypeScript pane where you will see the TypeScript project errors. So this step that we took of configuring WebStorm to use the exact same version that we are going to use in the command line of TypeScript is really important. If you use separate versions, you might get separate error messages and it would just be confusing. So please take the time to get this setup correct so that you can better enjoy the course. If you have followed these steps, you should now have a solid development environment to take the most out of this course. So let's get started writing our first TypeScript program. Now let's start coding. Let's go back to the terminal, and now we have here a folder with the complete TypeScript course. And we have confirmed that we can install the full version of our code. Now we are going to leave that folder there. We're going to see later how can we jump to different points of the course using it. Let's just leave it there untouched, and we are going to create a new directory. And you are going to call it maybe my project or something else that you want to call it. You cd into it, and this is an empty folder. Now we are going to turn this folder into a Node.js project. And there are two reasons for that. The first is that our REST API will be a Node.js REST API. But the second reason is that the Angular 2 client that we are going to build much later in the course, it will also be using Node and NPM, not as a server, but as a build tool. So Node has those two different usages. Let's get started. In order to turn this into a Node project, we are going to do npm init on an empty folder. At this stage of the project, you simply hit enter in all the questions, and this will generate in the end for you a package.json. So you should have now an empty directory with a single file, package.json. As you can see, the package.json file is a project descriptor. It contains the name of the project, the version, the description, and a couple of other properties. Also, it will contain the dependencies of our project. The first dependency that we use in our project is TypeScript, right? That's the first thing that we're going to need. We're going to install TypeScript in our project. So before we have installed it globally, but we are also going to say here that this project, the my project module package, depends on TypeScript, and the -D flag means that it's a development dependency. So let's install TypeScript locally to the project. If we inspect the content of the package.json again, you should have here in your dev dependencies property a version of TypeScript 2 or higher. So let's show that we have here a node modules folder next to your package.json. If you cd into it and you inspect the contents of the folder, you will see that you have here TypeScript installed. So this is a local installation of TypeScript. In these few sections we will be using the TypeScript that we have installed globally, but this installation of TypeScript that you have here, if you want to use it instead of the one that you installed globally, you simply do node modules.bin tsc, and let's do a -- version to show that this is the TypeScript that we have just installed. So we need to add TypeScript to our development dependencies. We can choose to use either the locally installed TypeScript or the globally installed TypeScript. In the terminal, it's more practical to use the global version of TypeScript. You might be wondering, what is the advantage of having multiple versions of TypeScript in your machine? Well, you could have a project that is dependent on TypeScript 2 and another that is dependent on TypeScript 1. And one only compiles in a certain version of the language because it's a breaking change. So that's one example. Now we have our Node project set up, so let's start writing TypeScript. Let's create our first TypeScript program. We're going to create here a file, and actually we are going to create here a samples directory, because in this first portion of the course we will be showing different features of the language in just a few small files. So we are going to create a hello-world TypeScript file. Notice the .ts extension. This identifies the file as being a TypeScript file. And here we have it, our first hello world.ts file. We are going to simply log something to the console just to show that the compiler is working. In order to compile this program, you simply cd into the samples directory. So you should be in the directory, otherwise this will not work. And you simply call the TypeScript compiler and you point it to the, in this case, the hello world.ts program. If we run this, everything was compiled correctly, meaning that we had no errors. But what was the output of this step? If you notice, you have here a small collapsible icon here in your hello world.ts file that was not there previously. So if you open it up, take a look, you have two files here in this directory. So these two files are the output of the compilation. So let's try to understand what's going on here. If we write the TypeScript file, if we type here something as simple as message, and we are going to assign it the hello world value that we had here, we can log it to the console, console.log message. So this is identical to what you would write in plain JavaScript. So if we run again the compiler, we are going to get a hello world.js file, which is basically identical to what we have written here. But TypeScript is a superset of JavaScript. So if, for example, you use here the let keyword, which is another way of defining a variable that has several advantages that we are about to learn, and we compile this again, now we will see a difference in the output of the compilation. Take a look. The let keyword was compiled into a var. But the let keyword is not plain JavaScript. I want you to bear that in mind, because now that we have confirmed that the compiler is working, that our environment is set up, we are going to start diving deep into TypeScript. We are going to learn why is it called TypeScript, what are the advantages of using TypeScript. It's coming right up in the next lesson. Before going any further in TypeScript and its features, I want you to have an overall view of what is the big advantage of using TypeScript. So imagine that you are a JavaScript developer, that you develop your programs in plain JavaScript. You will notice that the language is constantly evolving, meaning that there are new features that are being added to the language that are not implemented all at the same time in all the browsers. And you can only use the new feature when it's available basically in all browsers. Otherwise your program would break when you run it into certain browsers and not others. For example, let's take a look at the state of adoption of the let keyword. We head over to caniuse.com, which is the recommended place to go to find out if a feature is well supported across browsers, and we type in here let in the search bar. We might be surprised to find out that the let keyword is actually already available in most browsers. But what about other features that we're going to cover in this course? Let's take, for example, another feature, which are arrow functions that we will cover in detail. But it's a feature that we would like to use today. Well, take a look, it's not supported in Internet Explorer 11, which is still very used in the internet at this day. So we run into this situation where we have many separate language features, each one being developed independently and added in its own schedule to different browsers across the web. So this means that in many browsers we could already use the feature, but not in others. Well, we would like to be able to use the feature today. TypeScript helps us with that. And in what way? The TypeScript compiler takes the new features and converts them into plain ECMAScript 5 JavaScript. So let keyword is converted to var, and each feature has its own way of being converted into plain JavaScript. So this ensures us that we can use the new feature of the JavaScript language today, and it will still work across all browsers because the TypeScript compiler converted the feature into something that can be run in every browser. So that's one of the big advantages and one of the big reasons for using TypeScript. A second common reason to use TypeScript, a second big advantage of TypeScript, is the ability of defining types, like the name indicates. And that advantage is already present here, even in this very simple program. So this variable message has the type string because it has been initialized to a string. The compiler has implicitly associated to the string type. So if you now go here and, for example, try to assign it to a number, you will get an error. And if you hover over the error, you will see here type number is not assignable to type string. If you head over to the command line and you compile the program again, you will get the same error that we are receiving here on the IDE. So the error message on the console should be consistent with what you are seeing in the IDE. We can see how this would be useful. The type system of TypeScript is helping us build a more correct program. It's helping us catch bugs while we develop our program and not at runtime. Also notice that we did not have to tell TypeScript that this variable was a string. That was detected automatically, so this feature is known as type inference. But we could have also declared the message as a string by using a type annotation. So in this case, we are explicitly defining the message variable as a string. We are no longer relying on the type inference feature of the compiler. But if you are a JavaScript developer, you might be thinking at this point that sometimes this is exactly what we want to do. We want to be able to pass in either a string or a number to a certain configuration API and let the caller handle the fact that those might be two different types. So with TypeScript, we don't lose the flexibility of doing these kinds of things. We can still do it. We can declare here that this message variable is either a number or a string. As you can see, we no longer get any errors in the program. This feature that you saw here in action is a union type, and we're going to cover that in detail. I hope that now you have a better overview of what are the advantages of TypeScript. That was really what I wanted to transmit to you in this short lesson. So let's quickly summarize the advantages of TypeScript. You can use new features of the language today without waiting for widespread browser adoption that might take a lot of years. You can use types in your program to help you write a better program with less bugs. You have inferred types in your program, so you can take advantage of type safety even without using a lot of type annotations in your program. You still preserve all the flexibility of plain JavaScript if you still need it. You can still do everything that you could do in plain JavaScript in TypeScript. And last but not least, you can actually build your full application with it. You can build the front end and the back end with only one language, which would simplify tremendously our life as software developers. So how do we take it from here? Because there are so many features in the language, how do we approach the learning of the language? Let's start by exploring the new features of plain JavaScript that we can already use today, such as the let and the const keywords and many other features. Let's start by learning them first. We are going to cover that in this next section. Hello everyone and welcome, it's Vasco from the Angular University. In this new section of the course, we are going to start by presenting a series of ECMAScript 6 features that we can use already in TypeScript today. The goal is to present TypeScript as an improved JavaScript in a first stage. After that, we are going to dive deep into the type system, so everything that relates to types will be covered in a section after this one. Right now, don't worry, you will still have type inference at work mostly at all times. So your program that you are about to build will be type safe, even if you don't use any type annotations. Now, we're going to try to present the features as much as possible together, because many of the ES6 features are meant to be used together, and if we present them separately, it might not be as clear when should we use them and why. So, without further ado, let's get started. The first ECMAScript 6 feature that we're going to learn that is available if we use TypeScript is the let keyword and the const keyword. So we are going to compare these two to the plain ECMAScript 5 var keyword. Before we do that, we want to show that any program that we are writing, so this hello.world.js compiled output of TypeScript, this is runnable in a browser. So for that, what we're going to do here is we are going to install our first development dependency. We are going to install the HTTP-server. This is a very simple development server. We're going to install it with the -d installation flag. So this will mark it as a development dependency. This means that this would not be, for example, shipped to production. So if you open your package.json, you're going to see here that now you have here an entry which is the HTTP-server. Now we have here an index.html page. It's just a plain HTML page that points to the script that we are generating here. So notice that it does not point to the .ts file because the browser would not know how to run a TypeScript file. You need to point it to the output of the compilation, which is the hello world script. If we look in the Hello World program, we see here that we are simply printing a message to the console. So in order to execute this page, in order to load it in the browser, what we're going to do here is we are going to add here to our npm scripts section of our package.json, we're going to add here a small script that will allow us to load this page in the browser. So we are going to use the HTTP server that we have installed locally at the level of the project. And this executable will be available inside the node modules.bin directory. So there is an HTTP-server executable there. We're going to run it with the cache disabled to avoid any issues during your development, and we're going to point it to the current directory where the index.html file is. So we are going to call it ES6 because this is the file that we will be using to show that the ES6 features are already available today in TypeScript, and we're going to explain them one by one. Right now, let's just try this out and see our TypeScript program running in the browser. Let's try this out. If we head over to the command line and we type npm run ES6, notice that we started a development server here on port 8080. Now, depending on the port that is currently available, this might be 8081, 8082, etc. So HTTP-server will scan the ports trying to find the port that is available, and it will print to the console to which port it's running. So if we head over to the browser and we go to port 8080, we should see printed in the console "Hello World" as expected. So this shows how our TypeScript program can be run in the browser under the form of plain JavaScript. With our development server already set up, let's now start exploring the multiple ECMAScript 6 features that are available via TypeScript today. In this lesson, we are going to cover the let and the const keywords that we have been mentioning so far, but we didn't say what are those keywords useful for. So let's do that right now before going any further. So plain JavaScript just has a var keyword that allows you to define a variable. And what could go wrong with declaring a variable, right? That's one of the base functionalities of any language. Well, the var keyword in ECMAScript 5, so plain JavaScript, it has a problem compared to equivalent features of other languages. Let's have a look at it. Let's write a slightly more complex program where we are going to test for the value of message. So we are entering here a block. So in this block here, we want to define another variable, which let's say we are going to call it e. And we're going to define it as a number using a type annotation. Now I will just paste in here some very simple code that it's just a for loop. It's going to loop through the e variable and it's going to print it 3 times to the console. So let's try this out. Notice that you don't need to run again the TypeScript compiler from the command line. Your IDE is actually continuously compiling the program. So any changes that you made to the program, you simply hit Ctrl S to make sure that it's saved, and that will trigger a new hello-world file with your latest changes. So you can simply refresh the browser and you can see here that we have printed to the console the value of the e variable 012, which is what we would expect. But now take a look, this variable here, e number that we have defined inside this scope, this block, this is actually still visible outside the block scope, which is rather surprising for developers coming from other languages other than JavaScript. Let's print it out to see what's going on. If we simply print e to the screen after this loop, we would expect maybe that this would be undefined because this is a block scoped variable, but take a look. The value of e is still present there, okay? So this means that e, the e variable, is visible outside the scope of this block. This is because in plain JavaScript, using the var keyword is not block scoped. So if you define several blocks, several if blocks that are nested inside each other, and you would like to have a local variable that is only visible inside the block scope, That is not possible with the var keyword. And that is exactly the problem that the let keyword solves. So if now instead of declaring e as a var, we declare it using the let keyword, take a look at what happens. So this is still a variable, but you now get an error here, cannot find name e. So e is now a block scoped variable, so it's not visible outside this block, the if block. It's not visible in this statement here, the console.log. So block scoped variables are possible using the let keyword. This might lead to the question, should we still use the var keyword while doing TypeScript programs? I don't think so. I think that if you have a variable, you should always make it a block scoped variable and use the let keyword. Var is just there for backwards compatibility with plain JavaScript. Does this mean that we should declare all our variables using let? Well, actually, I'm going to suggest to you to prefer another keyword by default instead of let. So one of the best practices of developing programs that are easier to read and to maintain is to avoid mutable states. So if we declare here this variable as a const, we have effectively declared it as a constant. So this means that this variable is only populated at initialization time, and then later in the program, if we try to reassign it to another string, so the empty string would be a valid value for a string, but we have here left hand side of assignment cannot be a constant. So const is really a simple way of declaring a block scoped immutable variable. So let's summarize the three keywords var, let and const. So var does not have block scope. It should not be used while building new TypeScript programs. You should either choose let or const instead. And which one of the two to choose? We should use const if we want to declare the variable as being immutable, and this is generally a good idea to set a variable its value and initialize it only once, and try to build our program without relying on variable mutation. This is generally a good approach that leads us to less bugs. But if we need mutable variables, block scoped mutable variables, we can do that using the let keyword. One important thing to bear in mind about const is that when we apply it to a variable that it's an object, only the object reference is immutable. Try to assign message to null, we get back an error saying that we cannot do a second assignment to a constant after it has been initialized. But let's say that, for example, we want to change the property hello. Let's try that. As you can see, the program compiles, so declaring message as const does not mean that the whole object is immutable. It's only the reference to the object which is immutable. So to further illustrate this, let's say that we declare here a second reference to the same object and we make it not a constant but a variable. So we use let and we are going to point it to message. Now this second reference to the same object can be mutated because it's declared with let. So if we say message2 equals null, as you can see, the program compiles successfully. So it's important to understand that const is not about deep immutability of an object. It's really about creating an immutable reference, an immutable variable. So I hope that this explains the difference between the three keywords and when to use each. If you would like some of the code of this lesson, you have here the git tag section -1-2 where you can go directly to this version of the Hello World program. So now let's continue exploring more features of TypeScript, more features of the ECMAScript 6 standard that we can already use today. A feature that a lot of persons asked me in previous courses was to give the ability to jump to different points in the course automatically. So like for example, we want the code on section 7, we can jump straight to it. We want to go back to section 4, we can also do that. That is possible with Git, so you will have to have Git installed in your computer. And from there, from the command line, you need to do a git pull --tags to get all the tags in your local machine. Now, From here, if you do git tag, you are going to get a list of tags. So you can see here, these are the different checkpoints that are available for our complete TypeScript course. So let's say that, for example, we are at the state that we are at the end of the course, but we would like to go back to, let's say, section 2.1. So how can we jump to section 2.1? Let's do that. It's very simple. Before you continue, it's important that you do these jumps from different parts of the course into other parts of the course. I would suggest do that in a separate folder where you have cloned the repository, but you have not used that folder to actually build the program. So typically you will have something like this. You will have the TypeScript files, but you will not have here the output of the TypeScript file, meaning the .js and the source maps associated to that file. You only have the original source. I think this will give you the best possible experience. If you try to do this operation that we're about to do of jumping to a certain tag in your own repository where you are following along the course, you will probably end up losing some code unless that you are very familiar with Git. But if you do this in a separate repository, it will work perfectly and you can take the code from any point in the course. So let's do this. We are going to jump to section 2.1. To do so, we are going to type git checkout and we are going to add here tags, a /, and then simply the name of the git tag to which we want to jump to. So if we hit enter, we are going to get here a message that for the purposes of this course can be safely ignored. Now, if we refresh here our IDE, we hit here synchronize and we open again the collapsed folder, we can see that our folder has completely changed. We have here a much simpler setup than we had before. We can see that we have jumped to the beginning of section 2.1 as expected. Of course, using this functionality is completely optional and you can use the repository which contains the finished version of the course and take the code from there instead. Another thing that you can do is at the beginning of each section, clone again the Git repository, do a git checkout tag of the beginning of the section and take it from there. You will have at least the possibility to jump clearly to the beginning of each section using this method. Otherwise, basing yourself on the final repository is also a possibility. Again, doing this is completely optional, and if you don't choose to use this functionality of jumping to multiple points in the course, you will be able to enjoy the course without any problem. Let's now introduce another ECMAScript 6 feature, arrow functions. So as always, we're going to introduce the feature when we're going to explain what is the problem that the feature is trying to solve. Let's start with this simple program where we define a constant message. We have also defined here, using the function keyword, we have defined a function called sayHello, which takes as parameter a message and logs it out to the console. And here we are calling the function, passing it in the value hello world. If you go to the browser and we refresh it, we can see here that hello world is being printed to the console. Now, this syntax here has an alternative syntax. A function in JavaScript is assignable to a variable, so functions are values. They are valid values for a variable. So we are going to define here an immutable variable. We are going to call it sayHello, and we are going to assign it to this function body. So as you can see, this syntax doesn't work simply with the parameter and then the block scope. But if you add in here at this point the fat arrow, that's also how it's called, we have defined here a function that takes as input one parameter and logs it out to the console. So let's try this out to see that this is still working and this is still valid ECMAScript 6. So the arrow function is basically an alternative way of defining functions compared to the plain function keyword. But what's the advantage here? For example, if you only have one argument, you can actually remove the parentheses here. So if you try this out again, you can see that it's still working. Also, this function here only has one line. And that's a rather common case. Many functions are very small and only have one line. So in this case, with the arrow function, you can define it by removing the curly braces from around the unique statement of the function. If we try this out again, we can see that everything is still working. So this is one of the reasons why the fat arrow or the arrow syntax might be useful. It's a way of defining functions in a more abbreviated way. Now let's see another thing why this syntax is useful. It has to do with the use of the keyword this. In order to understand what is the problem that the fat arrow syntax solves relating to the this keyword, we have switched here to another small example where we are defining a function person, but take a look at the capital P. This is actually the definition of a constructor function. We're going to create here a new instance of person and we're going to pass it in the name of Bob. We're going to assign it to a constant person and we're going to call the method say hi. So what is the problem here? We are taking the name of the person and we are assigning it to this. So we are assigning it to the instance of person. But here we are defining a method. So this is like we are defining a class. But here also as a member variable of the instance person, we are defining here a method. We are defining a function that we can call named say hi, which simply calls set timeout, and we are going to wait here for 1 second. After 1 second, we are going to log out to the screen. Hello, my name is, and we want to pass in the name that we have passed in the argument of the person function. Now take a look at this warning, potentially invalid usage of this. Let's run this program and try to see what is going on here. What we get is hello, my name is, and then there's blank. There is nothing printed to the console. We don't get any error as well. So this is actually something. It's not undefined because this.name does not throw an error. So what's going on here? What happens is that in this case, this is pointing to the global scope of our runtime. In the case of the browser, this means that this is pointing to the window object. So what is going on here? What is the problem and how does the fat arrow syntax help to solve this problem? Well, the problem is that each time that we create a function using the function keyword, we are essentially creating a new scope as we have seen before. And inside the scope, this points to the scope, so we can use the scope to store information, to store variables. We are using here this.name to store the name of the person in the person instance. And here we are trying to retrieve it from the place where we have stored it. But here inside set timeout, we have created a new scope. Unintentionally, we have created a new scope. So here we are trying to retrieve this.name from this scope here of this function, and that is a different scope than the scope of this function here. So this is a behavior of the this keyword that is really not ideal when we're trying to do this type of programming. What we would like to do here is define an anonymous inline method here in the middle of the body of the function, but we would like to have the ability to create a new function without necessarily creating a new separate scope. We would like the this keyword to refer still to this person function so that we can retrieve this.name. How would we solve this in plain JavaScript? Usually what we would do is something like var that equals this. So we create a closure around this variable. We take that and we use it here. So now we can see this variable here. We have a new different value of this, but we can still see the variable that here. So that.name would point to this and we would retrieve the name. Let's see this in action. So as you can see, this would solve the problem. Hello, my name is Bob. But this is a little bit cumbersome and we would like to have a better way of solving this other than doing that equals this. And keep in mind this solution because we are going to see it in a moment. Now let's go back to the trouble situation. This has a different scope, so we get here undefined. One way of solving this is instead of using the function keyword to declare this function, we actually use the fat arrow function. Let's try this out. If we refresh the page, we get hello, my name is Bob. So whenever you define a function using the fat arrow, we are not creating a new scope for that function. We are reusing the scope on which the function itself is defined. In this case, the scope of person. Now, this explains another use of the fat arrow syntax. But you might be wondering at this point, how did TypeScript implement this? Well, if you look into the hello-world.js file, you will see that actually TypeScript did something very similar to what we did before, which is it created here a variable called _this that we had actually called that, if you remember, and it has used it here. So sometimes adding a new feature to the language, it's really as simple as this. So let's summarize. There are two reasons why the fat arrow syntax is useful for defining functions. It's an abbreviated way of defining functions without typing the function keyword everywhere. It's very convenient to define one-liners, for example. Also, in what relates to the this keyword, this avoids creating a new scope for the this keyword. So if you want to reuse your existing this scope, the fat arrow syntax is a great solution for that. One question that you might still have at this point is, should we still use the function keyword to define inline functions? I will suggest you to, whenever you are using inline functions, to always use the arrow operator syntax instead of the function keyword. It's more convenient, it's more concise, and you avoid problems that relate to the this keyword. The function keyword is great for example, defining functions that are named. So here is a suggestion of how to use this new functionality. Another very useful feature of ECMAScript 6 are template literals. For example, this expression here is concatenating two strings in order to produce a new string. There is an alternative notation to this, which becomes more readable if we concatenate even more values. Here we are only concatenating a single value, but if we use backticks here, so we add a backtick at the beginning of the template literal and we add a backtick at the end. We don't need the plus in the middle. So this also defines a string, and we can pass in variables inside this expression using this $curly brace expression. So inside the curly braces we are going to pass in this.name. So template literals are a great way of producing strings that are the result of the concatenation of several other strings. Another feature that template literals have is that they are multi-line. So if we add here multiple lines to the template, this is still working. Let's give it a try. As you can see, the multiple lines are here printed out to the console. This feature is extremely useful when concatenating long series of strings, or for example when defining the templates inline in Angular 2 components. You can define your template using backticks and have your HTML directly on the same file as your TypeScript for a given component. We're going to see how to do that further on in this course. Let's now present another ECMAScript 6 feature, which is called object destructuring. So if you want the code that you see here at this point, you can check out the tag section 1.4. Now what we have here is a build_person_data function that returns a string. This takes as input an object and it concatenates several properties of the object in order to produce another string. So we pass it in an object, person data, that has here a couple of properties, first name, last name, and address. Now, what is object destructuring? Let's have a look at it. Also, in these next few examples, we're going to start mixing several features of the language just to keep it more interesting. So for example, here we have an example of string concatenation. If you highlight this string concatenation in WebStorm and you hit Alt-Enter, you have here an option replace with template string. So as you can see, this creates a template literal that contains the same concatenation in a more readable way. Now, let's have a look at object destructuring. This scenario here is actually quite frequent. We are passing into a function, we are passing it in an object which has several properties. This could be, for example, a configuration object of a jQuery API call. It could have a lot of properties here. So accessing them using person_data.firstname, etc. in multiple places of a function can be quite verbose. So what we might end up doing is something like this. We declare here a variable first name and we assign it to person data. And then instead of typing everywhere person_data.firstname, we simply type the name of the locally defined variable first name. And we will do the same for the two other variables. This is what the program would look like after applying the same logic to last name and address. So this is doable, but it's a little bit verbose. We can instead use object destructuring and say that we are receiving an object, but we are only going to use inside this function certain properties of the object. We are only going to use first name, last name, and address. So let's try this out. We have here defined three variables. If we remove these, we can see that the program still compiles correctly. So the function expects an object with three properties and it destructures the object, applying something very similar to what we had here written, but implicitly. So first name is immediately available to be used in the body of the function. Now, what would happen if we would pass in here an extra property? This would still work, so the fact that we pass in an object with more properties other than first name, last name and address does not break the compilation of the program. What the destructuring syntax means is that we are taking these three properties because these are the only properties of the object that we need to implement this concrete method. So this gives for a more readable and simple syntax. Another feature of ECMAScript 6 that is very closely related to object destructuring, which is a syntax for creating objects, a shorthand syntax. Let's see in which situations this syntax is useful. Let's quickly refactor here the building of the person data object. Let's define this first name as a const. We are going to initialize it. And we're going to do the same to last name and address. So we have here just defined three constants and we have initialized them. Now we are going to use these constants to initialize the person data object. So the person data still has a property named first name, which has a value of first names. So the same name here is used to both the name of the object property and the name of the variable that contains the value of the property. So we would now pass in here also last name and address. And the same applies to address and last name. So let's have a quick look at what we have here. So there is a typo here. It's one of the things that TypeScript will allow you to catch at compile time. It's typos. Now this program is equivalent to what we had, but take a look, there is here some repetition. We have here first name and we have here first name again. Here is the name of the property of the person data object, and here it's the name of a variable called first name. This is a very common scenario actually, this happens a lot. So there is a shorthand notation for creating objects that are created in this situation. We can simply type just first name, last name and address, and this is equivalent to what we had before. So this is still creating an object with three properties whose values are the variables that have the same name as the property. So it's a very common scenario and you can see how this makes the program more readable. This example shows how many of these ECMAScript 6 features are actually related and meant to be used together. So object destructuring is a great way to take an object as an input and extract only a few properties and quickly use them in the body of our function. And the shorthand object creation notation allows you to, for example, quickly create a return type in a function simply using a few of the values that you have just defined. Let's continue presenting some more ES6 features, keeping it interesting, showing how they are meant to be used together mostly. But remember, very soon we are going to dive deep into the TypeScript to type system and see how it helps us to build better programs. And you have noticed, even in these simple examples, we are getting type safety errors. So even in these very simple examples, TypeScript is helping us to write our program. Let's now cover a couple of other ECMAScript 6 features that are closely related and can be better seen working together in a common example. Before we do that, let's have a look here at this program. It has a small error, so the build person data is expecting an object as input, and it expects that object to have at least these three properties with these three names, so first name, last name and address. But what we are passing it in is the person data object, which only has two properties, first name and last name. So take a look, even without any type definitions in this program, the TypeScript compiler knows that one of the properties is missing, and so it throws us an error in order to help us build a more correct program. In order to fix the issue, we have removed address here from the object destructuring of the buildPersonData function. But now we get here another error, which is cannot find address. So let's say that we would receive the address here as a second parameter. Now we have this error fixed, but we get here another error, which is the supplied parameters do not match the signature. This is because we are missing one argument of the function call. Well, let's say that the address in this case is optional. So how do we mark a function parameter as optional? One way to do it, we can make the address parameter optional by giving it a default value of, let's say, empty string. Like this, whenever we call the buildPersonData function, if the address parameter is filled in, then it will be taken and used inside the function. Otherwise, the default value will be used. Now, instead of making it a string, the address, let's make it a string array, such as what we have here in partial address. We have a street name, street number, PO box, etc. So an address is made of multiple strings. Type inference is still at play here, so TypeScript at this moment knows that this address is expected to be an array of strings. So if we try to pass it in, let's say for example, an array of numbers 0, 1, 2, we will get an error. And the error is argument of type number array is not assignable to a string array, which is what one would expect. So type inference is still at work even when we are just defining default values for a parameter of a function. Now let's build an address array and pass it into the buildPersonData function. So we are going to take the partial address and we are going to use it to create a new array. So let's call the new array address, and we are going to obtain it by taking the partial address and concatenating it with another array that, let's say, has here Staples Center. So now we can use this array and pass it in as the second argument of the call to buildPersonData. And this would work because this is a string array. Instead of doing the concatenation manually, let's use the array spread operator. Again, the benefit of the operator is more visible when we are concatenating a lot of arrays. In this case, what we can do is we simply take this literal here, Staples Center, and what we're going to do is we are going to add the content of the partial address array in the beginning. So we are going to spread the array using this ellipsis notation. So ellipsis, partial address, and then we add in another string to the array. So we have effectively created the same result as we had before. Address is the concatenation of the partial address array with this new string. In this lesson we are going to see the rest and the spread operator together in action and see how they are related. So here we have the array spread operator in action. Now let's rewrite a little bit the signature of the buildPersonData function. Let's say that instead of defining it as an array here of strings, we are going to simply say that we expect this function to have an undetermined number of parameters. So the first parameter is an object that must have a property named first name and a property named last name, but we don't know how many other parameters are going to be passed into the function, but we are going to group them all in an array named address. And this is what this ellipsis means here in this signature, in this method parameter. Here in this case, this is called the rest operator because it means that the rest of the parameters assigned to the function need to be grouped in this array variable. Notice that no compilation error is thrown and that if we refresh our program, we can see that everything is still working. This is an example of the small features of ES6 that will be useful to us in our day-to-day programming, but now we are going to introduce a major ECMAScript 6 feature, modules, and how that relates to TypeScript. It's coming right up. Let's now learn about ECMAScript 6 imports and exports, maybe one of the most important features. The other features that we have seen so far, they could be done by using just plain JavaScript and just doing it in a little bit more verbose way. But this feature is really critical for the development of the ecosystem. One of the main things about JavaScript, so the original version that ran through a long time in the browsers and still runs today, it does not have an import statement, and that is unlike just about any other language that you can think of. So if you want things to be imported from one file into the other in JavaScript, you don't have support at the level of the language, but you can do something similar to an import statement. Let's say, for example, that we would like this function build_data to be put in another file. We're going to call the file by the same name as the function that it will contain. We're going to call it build_data.ts. And inside we are going to pass in simply the function definition itself. Now what we will get here in the hello world program is an error. We don't see here in this file the build_data function because it was defined in a separate file. Now this program still compiles, and if we run it in the browser by adding this script first, then hello-world, things would still work. Take a look, you have here a build_data.js file, it's here. So if we simply copy paste the script tag and import it first, then the hello world.js program, this would still work. So let's give it a try. As you can see, the program is still working as before, and if you check here in the network tab and you filter by JavaScript files, you can see here that there are two JavaScript files being imported, build_person and hello world. So despite the fact that we have here a compilation error, the program is actually still running, because when the program runs in the browser, the build_data function has been added to the global scope of the program. You can imagine that this would get cumbersome very fast because we are basically polluting the global scope. We are creating a global variable which is a function, build_data, and we are retrieving it in another file. Also, here we only have 2 script tags, but imagine that there are 20 script tags, and this can happen very fast in a real program. It becomes very hard to maintain the order of those tags, especially if your site has multiple pages that not all of them use all the tags. Keeping the order in sync across several pages can become unmaintainable really fast. This missing language feature, the missing import statement in the original version of JavaScript, was compensated by the introduction of module loaders in the JavaScript ecosystem. We're going to see how they work and how they solve these problems in the next lesson. So how do we solve the problem that the ECMAScript 5 language does not have an import statement? To solve this problem, ECMAScript 6 provides us with the import and export keywords. So if we go here to this file build_data and we export this function, we are publishing it so that it's available for import in other files. If we now go to the hello world file and we hover over the build_data function, we have here, if we hit Alt Enter in WebStorm, we have just automatically imported the build person data function from the file with the same name, which is located in the same directory as we are. And here inside the curly braces, we just have to add which parts of the file do we want to import. So you could also have exported here a constant. So let's export here a constant named demo, and we're going to call it demo only. So this constant is also available for import here. So if you hit comma and you hit control space, you're going to get here demo, also available for import. So you can export functions, constants, variables, also arrays, classes, basically anything that you can define and assign to a single variable or constant, you can also export and make available to other files. Now what we can do is we can go back to index.html and we can actually remove this script because it's no longer necessary. But if you now hit reload and try to load this new program, you're going to get required is not defined. And what does this mean? Let's take a look at the file that we are trying to load. We're going to try to load the hello-world.js. So let's take a look at it. So now that we have added imports and exports to our program, the program all of a sudden looks quite different. You have here these require functions being called. You also have here, for example, if you go to build person data, the JS file, you have here a call to exports. We are trying to populate an object which is called exports that does not exist. And here we are trying to call a function that does not exist, required. So how did this happen? Because this is being generated by the TypeScript compiler. So what is going on here? What is exports and what is require? Let's start first here with the exports call. So what is happening here? TypeScript is trying to use the CommonJS module syntax to define a small module. So this file, it's trying to make it a module and it's trying to populate the Node.js CommonJS exports variable, and it's trying to assign to the build person data property the value of this function right here. So what TypeScript is trying to do here is, by default, it tries to compile a file where we have exported something. So I'm going to open here the file. By default, TypeScript is trying to convert this file with an export into a Node.js CommonJS module, which is a very simple syntax for defining modules. But the problem is that although this syntax here, where we export something using exports and then we can import it somewhere else using require, so we have here the require statement, so this is also a function that is available in the Node.js runtime. It's the CommonJS way of importing modules in Node.js. The problem is this functionality, the CommonJS module system, it's not available in the browser. So the first time that we try to use it, which is by calling require, we get require is not defined because the browser does not support CommonJS out of the box. So how do we solve this? We are going to find out in the next lesson. Another thing to bear in mind is CommonJS is just one of the several module formats that the TypeScript compiler can convert the keywords import and export into. It's the most commonly used format, and it's the format that we recommend to be used at this moment. So let's find out how to use these files in the browser. So how can we run files like this, a CommonJS file that uses the require and the exports CommonJS syntax in the browser, if the browser does not understand CommonJS? The solution is to use something that is known as a module loader, so something that understands files written using the require and exports syntax and can make them work in the browser, even though this functionality is not available there. In this example, we are going to use a module loader called System.js. The advantage here is that this is only a module loader. This is not a bundler, so it's not bundling files together. In this case, we are just going to use System.js to add to the browser the ability of loading modules in the CommonJS format. So we start by adding the latest version of System.js to the browser via simply a script tag. And notice that the order is important. This script tag loading System.js needs to be the first script tag in your HTML page. Otherwise, we are going to get again require is not defined. Now the next thing that we need to do is to configure System.js to load our program, whose entry point is hello-world.js. One thing to bear in mind about System.js is that it does not really add the require function to the browser. So it does not add the equivalent of the System.js module loading system that is available in Node.js to the browser. It adds something with similar capabilities, but the API is slightly different. So for example, we're going to start by removing from here this script hello-world.js because, as I've mentioned, the require function will not be available globally. So let's delete this. Instead, let's create here a small script that is simply going to load the Hello World program. So we are going to use the System.js API, which will be a standard browser API in the future, and we are going to do system.import, and we are going to import the file that can be found under samples, and it's simply going to be hello-world. Now, we are not adding hello-world.js. Let's try to do that. If we load the program, we can see that the hello-world file was loaded, and we did not get a require is not a function error, so that worked okay. But after that, the hello-world.js file tried to import the build person data, and noticed without the extension. So we need to do a small configuration in System.js. We need to configure it so that the default extension that it tries to fetch with each require is the .js extension. So if we remove this here and we now try this out again, now everything will work, meaning we managed to load the hello-world file, the .js file. That file required another file that was also correctly imported. So if we go here to the network tab and we filter in JS, so if we reload here the browser and we look at the network tab, we can see that first we load the index.html page, then System.js, then hello-world.js, and then buildpersondata.js. All of these derived from a single import. This system.import call right here loaded the hello-world.js file, and that file had a require statement to get another file. System.js handled that require call and triggered another request to fetch the buildpersondata.js script. So we can see here that using a module loader solves not only the problem of being able to split our program into several files and getting a working import statement, we also no longer have to order the scripts by the order on which they are used in the page. We just have to point to the entry point, and the module loader will know how to fetch the next script. So to summarize, ECMAScript 6 gives us an import and an export keyword so that we can import the content of a file into another file. That is available. Under the hood, TypeScript will convert that into typically CommonJS format, although other module formats would also be supported. In the browser does not understand by default CommonJS, so we need something to enable the browser to be able to read those files, and that is a module loader. Another role of the module loader is to know how to fetch the different files from the backend. In this case, we are getting the files, the CommonJS files, via AJAX requests, and we are basically evaluating them and registering them in a central registry of modules so that they can be imported anywhere in the application. So in the case of the import and export keywords, it's important not only to know how they work, but also what's going on under the hood. Knowing how this works will allow you to, for example, choose a module loader set up the configuration of your TypeScript compiler to create the correct module format, and it will also allow you to troubleshoot your environment, especially in the initial stages. After learning all about the cool features of ECMAScript 6 that TypeScript allows us to use today, we're going to now learn in this section and in detail the biggest feature of TypeScript, its type system, that actually gives it its name, TypeScript. We're going to learn the type system in detail, how to use it to build type-safe programs, and what are the advantages of building programs that way. Let's do some quick initial setup to prepare our environment to explore the TypeScript 2 type system. For this, we are going to create here a file, learningtypes.ts, and we are going to create here an npm script types examples. So whenever we want to run the content of this file here, learningtypes.ts, so this is currently empty for the moment. So if we add here simply a console.log section 2, let's now run this program, and we are going to use this npm script here. So we are going to do npm run types examples, and this is going to call the node executable to execute the learning/types.js file, which is here at the same directory as the ts file. This is being compiled automatically by your IDE. So if we run the program, we should have here in the console section 2. So our sample file is working. Let's now start learning the TypeScript type system. Let's now start learning the type system. So let's start by the primitive types. We have already seen before that we can define a string by simply initializing it with an initial value. So in this case, the message variable is a string because it has an initial value of hello world. We could also explicitly define it as a string using a type annotation. This is also applicable for numbers. So for example, if we have here a variable named counter and we initialize it to 0, we can see that the variable is now a number. Actually, let's make these two instead of constants, let's make them variables so that we can attempt to mutate them. And if, for example, we now say counter equals message, we are going to get an error. And the error says the type string is not assignable to the type number. So the counter variable has an implicit type of number that we can also make explicit by a type annotation. Remember that a number in TypeScript, like in JavaScript, this is a floating point, so you can also represent non-integer quantities, such as, for example, 1.2. And if you try this out, you can see that this number is correctly represented. But take a look, because this is a floating point, you should be aware when, for example, adding two floating point numbers, this is not going to be exactly 0.6. So if you try it out here, you can see that we get a little bit more than 0.6. So this is not an error. This is the normal behavior when we are adding two floating point numbers. It's just something that we need to bear in mind when we are doing calculations with numbers in TypeScript or in JavaScript in general. I would suggest to you, if you are building a program where, for example, you need to add monetary amounts, such as, for example, dollars, I would suggest to do the calculation in cents of the amount, so using integers. And then if you need to show in the screen, let's say $10.12, at that moment you can format the result of the calculation, but it's better not to do the calculation with non-whole numbers to avoid this issue. Another very commonly used type is the type boolean. So let's say, for example, that you have here a flag called messageRed, which can either be true or false. So again, you can initialize it to either true or false. So again, if you initialize it to a boolean, this variable will implicitly become a boolean. And in order to confirm that in WebStorm, you can click over the variable and hit Ctrl-Shift-P. And you will see the type of the variable that is inferred by the compiler. Let's now cover objects and types. Let's take this very simple plain JavaScript object that has two properties, so first name and last name. You might think that the type of this object is object. I mean, it should be a type that takes any property. This is what we would be led to believe, but take a look. If we try to add here another property address, we are going to get an error. It says property address does not exist on type. And we have here what looks like a type definition, which is an object that can only have two properties, either first name or last name. We're going to see in a moment how to configure the TypeScript compiler to allow such situations if we want to. But right now, let's focus here on this person variable. It's clear at this point that the TypeScript compiler is already defining a type and associating it to the person variable. If we hit Ctrl-Shift-P, we can see that the type is defined here, so it's first name and last name. So the type defined is an object that can only take these two properties. We could have defined this type explicitly by adding a type definition and defining the type here in line. So we will define the first name that needs to be a string, and we are going to define the last name, also a string. So as you can see, the program compiles perfectly and it's equivalent to the version where the type is inferred. Now we might want this to be just a plain old JavaScript object that could take any property. If we want to do so, we can remove this type definition and we can annotate here explicitly the type any. This means that this is an object that can have any property. And as you can see, we no longer get here a compilation error. We can do person.address or person.any other property. And also take the type definition of what we had before and define a type. Let's create a type called hasName, and we are going to assign it here this type definition. So hasName is an object with these two properties, which are strings, and only with these two properties. We can now use the name to define that person is of type hasName, and now we get back again the error property address does not exist on type. So as you can see, in TypeScript we can define our own types, and those types don't have to be the definition, for example, of a class or a primitive type. We can define complex types and compose them together. It's also possible to say that, for example, the last name property is mandatory, but maybe the first name property is optional. So let's say that, for example, we only had the last name. Right now, this will give us a compilation error saying that the property first name is missing. But if we define it as optional using this syntax, now the compilation error disappears. At this moment, you might notice that hasName, this kind of looks like an object-oriented interface. And actually, if we use here the keyword interface and we remove the equal sign, this is actually an alternative definition of the type hasName. We're going to learn when to use an interface and when to use the type definition in a later lesson. Right now, we are going to show that there is another important feature in action here at this stage, which is autocompletion. So if you do person dot, you will see here the multiple properties available via autocompletion. And this is something that is not available while using plain JavaScript. Now, one last example of type definitions. We can compose types together. So for example, if we define a new type hasAddress, which let's add here a property, street name, which is a string. We can now define a new type and let's call it person. And this is the combination of a name property, which is of type hasName, and notice the autocompletion again in action, and the address property, which is of type hasAddress. So we can define here person as being of type person. And as you can see, this is no longer working. We can add here a property name and we pass in the last name inside it. We still get an error. This means that the address property is missing, so we can mark it as optional. And now we no longer have compilation errors. So as you can see, these type definitions can be combined together to produce complex types. In TypeScript and in JavaScript in general, functions are also valid values that can be assigned to variables. So let's say, for example, that we create here a variable named hello. We can assign this, of course, to a string hello, but we could also assign it to the create hello message function definition. So a function definition in TypeScript is a valid value for a variable, and in JavaScript as well in general. A function is in itself a value that can be passed around in the program. Now take a look at this parameter. We are not defining it as a string here, so this could be anything. Here we are passing in a string, Bill, and if you run the program we get hello, my name is Bill. But we could have passed in here also, let's say for example, an object with first name Bill. If we now run the program, we can see that we get object printed to the console. So this is the default toString of object. So as we can see, this program is actually not type safe in the sense that we can pass in anything in create hello message, and we would probably want to restrict the type of name to be a string and not an object. So to improve this program and make sure that this accidental call of the create hello message does not happen, what we can do is we can add here a type annotation to the function parameter name. And now we can see that we get here an error. Argument of type first name string is not a string. Also take a look, this function here, create hello message, is returning a string, but we are not defining a return type for this function. So let's say that, for example, we define here a variable named message, and we are going to pass it in the output of calling the function. So we pass it in create hello message and we call it with an argument of Bill. And now let's log out the message. So this is still a valid program, and if you click over message and you hit Ctrl+Shift+P, you're going to see that the type of this variable is inferred based on the type of the return inside this function. So TypeScript still knows that this message is a string, but we can also explicitly add it here. We can add a type annotation that defines what is the return type of this function, and in this case the return type is string. Now we might have many such functions in our program that create different kinds of messages. So functions that take a single input argument as a string and the parameter is mandatory and it returns a string. So we can define here a type definition, and let's call it message creator. This type definition is going to be a function that has as first and only parameter of name and type string, and whose return value is a string. So this defines a function type. Message creator is a function type. With this function type we can for example define here a constant named creator, which is of type message creator. So this means that creator is a variable that can only be assigned a function with this definition here. So create hello message is an example of such a function. So if we assign it to creator, the compilation error is fixed. Let's use creator to call it with the parameter Bill, and let's run the program. So as you can see, everything is still working as expected. Now say that we have added here a second parameter, so let's just call it extra, and this is a number type. If we add here a second parameter to the create hello message, now we get here an error because this assignment is no longer valid. We are trying to assign a function that has two arguments as input and returns a string, but message creator can only take one argument as input called name. This would be solved if, for example, we declare this extra as optional. We can also define a function type as being an interface which only has one method. So let's say that, for example, we define the message creator like this. So interface, message creator, and in here we have a type definition that is very similar to the definition of a function. So we have here an argument which is name of type string and a return type of type string. If we now try this out, we can see that everything is still working as expected. So this is an alternative way of defining a function type. Let's now cover how TypeScript allows us to do strong typing of arrays as well. So we have here an array which is an array of strings. If we hit Ctrl+Shift+P, we can see that actually the type is not array of string. Notice the pipes between each of the elements of the array. More on this later. Right now, let's define here another array. So it's an array of numbers, and we are simply going to assign it the values 0, 1, 2, for example. And again, let's inspect with Ctrl+Shift+P the type. This is a type of number array. So let's now try to assign, for example, to the counters variable. So it's declared with let, so we can assign values to it. Let's assign it the persons variable. So as you can see, we get an error. Type string array is not assignable to type number array. So again, we have type inference in action here. We did not have to define the type for these two variables, persons and counters. They have been implicitly found by the TypeScript compiler. But we could define them explicitly if we so wanted to by using a type annotation. So let's annotate the two variables, and as you can see, the program still compiles except for this error here that we can remove. Let's go back to the persons string array. If we now hit Ctrl+Shift+P, we can see that this is now defined as a string array. But if we remove this type annotation and we hit again Ctrl+Shift+P, we have here something else. So what is this? Why are there three string declarations here? And if we remove one element and we hit again Ctrl+Shift+P, there are only two string elements there. So what is this? Implicitly, TypeScript is interpreting this type right now as a tuple of two strings. So let's define another example of a tuple. Let's say that we have a tuple which is a pair of a number and a name. So first element of the tuple is a string and the second is, for example, a number. Let's say that it's 5. So we have just defined here a type which has two elements in it, a string and a number. If we hit Ctrl+Shift+P, we can see that that is exactly the type that was defined. This means that we can define a type which is a tuple. Let's call to the type the player tuple, and we are going to define that this tuple has a first element which is a string and a second element which is a number. Now we can say that the variable tuple is of type player tuple. And the program still compiles correctly and everything works as expected. So this explains the type that we were seeing here. We are not limited to only two elements. We could define three elements. So we can see here by hitting Ctrl+Shift+P that we have implicitly associated to persons a type which is an array which has three strings. This means that we can define a type which is, let's call it three names. This tuple takes three arguments and three arguments each one of type string. So we could say that persons, this array here, is of type three names, and the program would still compile correctly. TypeScript also gives us enum support. So let's present here a simple example where we have a type which is named player, which is a tuple of a string, which is the first name, and the number. But the number, it's either 0, 1 or 2. 0 meaning that the player is a guard, 1 that it's a forward, and 2 that it's a center. So we have here three players defined, each with its own position in the field, and we have here an array of players. So we are using multiple features already of the type system. Let's print to the screen the result of this program. So as we can see, everything is working as one would expect. To improve further the type safety of our program and the readability, we can define an enum. So this is the syntax. We use the enum keyword, we define the name for the enum, and inside curly braces we define the three possible values for the enum, in this case guard, forward or center. We can now use the enum type to further specify what is the type of the second element of the player tuple. Using the TypeScript autocompletion feature, we can use it to define here a more readable program where we are using the enum instead of plain integers to identify the position of the player. So if we now run our program, we can see that everything is still working. And take a look, the enum was actually translated into 0, 1 and 2. So basically whenever you create an enum, that at runtime will be translated to simply an integer starting at 0. So guard, because it's the first position in the list of possible values of the enum, will be assigned the integer value of 0, forward 1 and center 2. Another important feature of enums is that, let's say that we have an object which has a string property which is the word guard. If we would like to obtain the corresponding enum value based on that string, we can use here the array notation in the following way. If we use player position of guard using this notation, we get back 0 because it's the first element of the enum. So if we run this program now, we see that we get back here 0. So we managed to convert the string guard to its corresponding enum value, which at runtime will correspond to the 0 integer. Let's cover some TypeScript 2 specific functionality, nullable types. So here we have defined an enum called player position, and we have defined an interface player with a name and a position properties. Now we have here an object which is called Kobe, which is of type player. So let's add the type annotation here. Now this variable Kobe is of type player, but we could also assign it, for example, null, and we could also assign it undefined. And this would still compile, this would still be a valid TypeScript program. But we might not want this functionality. We might want to ensure that this variable is an instance of player and that by some reason it cannot be null or undefined. We would like the type system to help us define that, declare this rule. In order to do so, let's configure the TypeScript compiler to turn on the strict null check mode to prevent this situation from occurring. For that, let's head over to the command line to the root of our project. So take a look, we are in the root of our complete TypeScript course folder repository. Now we are going to do tsc ---- init, and this created here in this folder, it created a tsconfig.json. This file is a configuration file that configures the TypeScript compiler with some commonly used options. Actually, until this moment in the course, we were actually using the TypeScript compiler via the WebStorm IDE, and these options were actually already active. So, as we've seen before, whenever we use import and export that ECMAScript 6 syntax for modules in our program, we were compiling our program to CommonJS. We saw that before. We were compiling imports to the require statement and exports to populating the exports property. As we can see here, we were already using our target as ES5, meaning that we are compiling to a version of JavaScript that is currently available in all browsers. We could compile TypeScript down to ES6, for example, if our target platform would be ES6 enabled, but we compile to ES5 in most cases. Now take a look at these other two options. No implicit any set to false. We are going to cover what no implicit any is in a moment. Source maps, we will also have a specific section for debugging, so these two options will be explained later. Right now, we want to add here an option that is available since TypeScript 2 that will prevent this situation from occurring. So the ability to assign undefined to a variable that should be of type player. So in order to do, the property that we are looking for is strict null checks, which is by default false. We want to set it to true. Also, at this moment, we want to configure WebStorm to use this tsconfig. So use tsconfig. So this is why it's important that you put the tsconfig.json file in the root of the project so that WebStorm can take it from there. If you put it in another folder, WebStorm will not be able to use it, and you will have differences between the errors that WebStorm is displaying you from when compared to the results that you would get from the command line. So this way you will get the same results in both environments. If we go back to the program, we can see that now we get an error for this situation. So it would take a moment for the compiler to be adjusted to the new options, but we can see here that now we get type undefined is not assignable to type player. You can also see the same error here in the TypeScript pane in the WebStorm IDE. You have a list of errors of the current program. So we have effectively prevented this situation from happening. We cannot also assign it to null. If we try to assign the variable Kobe to null, we get type null is not assignable to type player. So this is exactly what we expected. As you can see, this functionality is really very useful to catch all those null-related errors that tend to pollute many of our programs, also errors related to undefined. So you might think, why isn't this option turned on by default? Well, this is so with TypeScript 2 due to backwards compatibility. So we want to make sure that programs that are written with TypeScript 1, we want to make it easier to migrate them to TypeScript 2. If we would have strict null checks set to true by default in TypeScript 2, that would introduce a major breaking change that it would make quite hard to migrate many programs from TypeScript 1 to TypeScript 2. So currently it's set to false by default to make it easier to upgrade to TypeScript 2. But if we are writing a new program, it's a great idea to turn this flag on since the beginning, because this is one of the main features of TypeScript 2. Now let's go back to this program. There are situations where a variable can be nullable, so it could be an optional variable. Sometimes it's null and sometimes it contains a player, an instance of player. So how can we tell that to the type system so that this program compiles correctly? We can use a union type for it. We can say that the Kobe variable is a player or null. And now the program compiles correctly without any errors. Notice that if we assign this to undefined, we still get an error. Type undefined is not assignable to player or null. So we could take this one step further and we could add here the type undefined. And with this the program would compile correctly. So now with TypeScript 2 we get the possibility to say which variables are nullable, which variables can be undefined, and which variables are expected to always contain a value. So in the program that we are about to write, the REST interface that accesses a SQL database that we will be building in a moment, we are going to use strict null checks from the beginning. Take a look at this simple function that takes a parameter name, which is a string, and returns us back a string. As we can see, the program compiles correctly because we don't have here any errors in the TypeScript pane. Now let's change slightly the implementation of create message. Let's say that we add here some branching. So we are going to return the message only if the name property has a value. So we are going to do if name, we do a return. Now take a look, all of a sudden we have an error here. So this would work in plain JavaScript, but here we get an error, and you can see that you will see the error both if you hover over the error, and here in the current errors pane we can see function lacks ending return statement, and the return type does not include undefined. So many times the error messages that the compiler gives us are actually quite readable. If we don't add a return statement here after this if, this will implicitly return undefined. So this is the behavior in plain JavaScript. If we don't add a return statement, implicitly we are returning undefined. And we have here an error, undefined is not assignable to string. So if we remove this implicit return statement, we get a similar message. We could make this compile by adding here a union type and say this is either a string or undefined. But most of the times this is not the result that we want, and indeed the control flow analysis functionality of TypeScript did help us to catch a mistake in this case, so this error is correct, we should return here something. This is an example how the TypeScript control flow analysis functionality can help us catch errors in our programs. In this section we are going to cover union types, intersection types, and when to use the keyword type versus interfaces. So let's start with a simple program. We have here a plain JavaScript object named player that is getting logged out to the screen. So if we run the program, you can see that the object is printed to the screen as expected. Now we would like to make this variable more type safe, because right now it has the implicit type any, and we're going to see in a moment how can we prevent that the TypeScript compiler adds any implicitly to certain variables. Right now we want to add a couple of type definitions. HasName, which has two properties, first name and last name, and HasAddress, which has a property of address. So this player object actually conforms to these two interfaces, so it has all the free properties on the two interfaces. So we would like to add here a type that is different than any that reflects that. In order to do so, we can create here a type alias, and we are going to call it player. So this type alias is an alias for a combination of other types. So in this case, we are going to use HasName and HasAddress. So any object of the type player will implement the two interfaces. It will have the properties of both these types here. If we go to the player variable and we declare it as player, the program will still compile and run as expected. Now take a look. If we remove one of these variables here, we immediately get a type error saying that the variable is missing. So let's add it back for the moment. What we have defined here is what is known as an intersection type. Now we can also combine this with union types. We have seen union types before when dealing with nullable variables. We can say that this variable here is either a combination of these two types or null. Now we can see here that the type keyword is being used to define both a type alias, which is the combination of these three types, and separate object types. This syntax here is actually equivalent to using the interface keyword, which in TypeScript is not only associated to object-oriented programming. So we can define interfaces that an object can comply to. It doesn't need to be an instance of a class in the object-oriented kind of way. So in TypeScript we can define interfaces that an object should implement, not necessarily a class. So instances that adhere to the interface will have the properties defined in the interface, but they don't need to be instances of a class in the object-oriented sense. As per the TypeScript documentation, this is actually the recommended way that we should use interface and type. So we should use interface to define properties that an object will adhere to, will have, and once those are defined, we can then use the type keyword to define type aliases that combine other types together. This is a great time to introduce the TypeScript any type. So let's declare here a variable which is of type any. We are going to use the let keyword, and we are going to name it myVar. We are going to use a type annotation to specify that this is of type any. Now, what can we assign to myVar? Let's try to assign a number. As you can see, you get no compilation error, so assigning numbers to any works. What about strings? Also no compilation error. An empty object or arrays? This also works, so we can assign anything to a variable of type any, including null and undefined. So far this is more or less intuitive, giving the name of the type any. But what might not be apparent at first sight is that not only can we assign to myVar anything, but we also can take myVar and assign it to anything, which might be a bit surprising the first time that we found this functionality. Let's say, for example, that we have here a variable which is a number, and we are going to implicitly assign it the type number via type inference. So if we hit Ctrl+Shift+P, we can see that we have here a number as an inferred type. Now, can we assign to counter the value of myVar? Let's have a look. So we can see here that we could assign myVar to counter. That is absolutely not a problem. I'm going to remove this assignment here so that it really doesn't change anything. We can assign to counter a type any. And what about, let's say, a string, and this time I'm going to use a type annotation to explicitly assign it the type string. Can we assign str to any variable? Let's give it a try. So as you can see, we can also assign to a string a type any. But at this point, we really have no guarantee that myVar would have a string. This could be, for example, an object. And the type system is not throwing us an error. So this is valid code. This is the most important thing to keep in mind about any. We can assign it any value, and we can take it and assign it to anything else. Any is really a way of opting out of the type checking of the TypeScript 2 compiler. This is here present in the language, especially for compatibility with third-party JavaScript libraries that were not written in TypeScript. So for those cases, any comes very handy to write our programs. It's a great time to introduce a new compiler feature, implicit any. So if we remove this type annotation, the program will actually still compile. So let's run it here quickly to see that everything is working as expected. As we can see, it still works, the program. But we would like to prevent this situation. We would like to prevent that the compiler automatically assigns to a variable the default type of any if it cannot infer the type. We would prefer to receive a compiler error saying that the type of this variable is unknown. If we want to force that behavior, we simply go to the tsconfig.json and we change the value of the no implicit any variable from false to true. So this means that the compiler will no longer assign implicit any to certain variables or function return types. If we go back to our program, we might be surprised to find out that this statement is still compiling, and if we hit Ctrl+Shift+P on top of the player variable, we can see that the TypeScript compiler was not assigning any to this object. So the compiler was determining that the object followed this type, so it contained these three properties. So this was not an example of where an implicit any might occur. But if we create here a function, let's say that the function is named createMessage and it takes an argument of type message. Now we can see that we get here an error. Parameter message implicitly has an any type. So this is the case where the compiler typically will assign any types in input arguments of functions to which we did not add a type annotation. Before, the compiler was implicitly adding here any type, but now we are getting an error. And we can fix the error by explicitly defining the type of the method parameter. Now the error in the learning types file is fixed, but if we look here at the error panel, we can see that there are a couple of other errors, so let's fix them as well. This is in the build_person_data file. Let's see the error. One way of fixing the error would be to define a type that has a first name and a last name and apply it here, but nothing prevents us from also using the any type in this case. So we still have the option of using anywhere in the program where we would think that it's a good solution. So in this case, I'm just going to define address as any array, and now our program compiles again. So if you have an existing code base and you turn on this flag, no implicit any, you will have some refactoring involved. that is why the flag is false by default. But if you are writing a new program, I would advise you to turn on the flag and set it to true, and strict null checks also true. This way you will have the best experience while developing a program in TypeScript, taking advantage of all the type safety features that are there available, but that for the moment are temporarily off by default, mostly to ensure an easier migration from previous versions of the language. Being able to write type-safe programs is a great feature of TypeScript, but what about third-party libraries? Let's install here a very commonly used third-party library in our project. It's called Lodash. This will allow us to do data manipulation, for example, to handle arrays of data. In order to install it, we type npm install lodash --save. After a moment, the latest version of Lodash will be installed and Lodash will be added here as a dependency in our package.json. Now we can use Lodash in our program, so let's simply import it here by using the CommonJS require statement. We are going to import Lodash and we are going to assign it to this constant. Now notice one thing, we have here a TypeScript error, cannot find name required. So the TypeScript compiler does not know the require function. This is a Node.js specific function. We're going to see how to solve this problem in a moment. First, I would like to show you that despite the fact that there is an error, the compiler is still producing an output that can be executed. So let's say that, for example, we have here an array of colors. We could use Lodash, even though we have a compilation error, we could use Lodash to extract the first color from the colors array. So if we do console.log, we should expect to see red in the console. If we try this out, we can see that the color red is being printed, which shows that the program is still working despite the compilation error. Now, we might not want this behavior. We might prefer to prevent the TypeScript compiler from generating an output if it finds an error. So in this case, we need to go to our tsconfig.json and we choose the no emit on error option, which is by default false, but we are going to set it to true. If we go back to this file, learning types, and we delete the output of the compiler, we hit Ctrl S, and we're going to see that now no output is being generated because an error is found, cannot find name required. So how do we fix this? Besides this error, cannot find name required, there is another problem here. The underscore variable, we don't have autocompletion to know which methods are available in the underscore library. So this is a situation when we are using third-party libraries. We want to import a type definition for the library, if it's a plain JavaScript library, so that we can use the features of TypeScript even though the library itself was not written in TypeScript. With TypeScript too, we can import type definitions directly from npm. So let's first install the type definitions for the Node runtime environment, which will include the require function. So to install it, we simply install npm install @types /node. So this will import us all the type definitions for a Node.js runtime so that we can write Node.js programs in TypeScript. We are going to add --save dev, or if you prefer the shorthand -d. This will install the typings. Here under Node modules, you now have here a folder @types, and if you open it, you can see here that you have the type definitions for the Node runtime. And also you can see that the TypeScript compiler is by default configured to implicitly look inside this directory. So you do not need to add any specific configuration to the tsconfig.json, defining the typings roots, etc. for using it with @types. Any type definition that you install using @types will be implicitly added to your program. Now let's take a look at the required type definition. If we go here and we hit Command-Shift-F and we search by the word required, we can see here in this search result that require is defined here. require is of type nodeRequire function. So this is a function type definition. We are using an interface with a single method. And you can see here what the declaration of the Node.js runtime typings look like. So this gives us autocompletion for all this functionality that is available in the runtime. So let's now do the same for Lodash. If we do npm install @types/Lodash, we are going to have the Lodash types here installed as well. So if we go to package.json, we have here as development dependencies @types/Lodash. If we go to node modules, we can confirm that the Lodash types are there. But we are still not using them in our program because we are using the require statement. So how can we take advantage of the Lodash type definitions? In order to know the type of the functions that are exposed by Lodash, we should import it not using the require statement, but instead we should import it using the ECMAScript 6 syntax. So we are importing from the Lodash module. We are importing anything that the module is exporting, so it should only export one variable. So the CommonJS module of Lodash should only export one variable in order for this to work. And we are renaming whatever we receive from that export as Lodash. Let's try now autocompletion to see what functions are available. So we can see here that all the type definitions for the functions that are available in the Lodash data manipulation library are here available via autocompletion, and this is very useful to build our program. Notice that the node types are global, so that is typically the use case for @types. We don't need to always install an @types module in order to add types to a given module. There are many modules already available like Firebase, AngularFire 2, which already come with their own types whenever we install them. So for those specific modules, the TypeScript compiler will take the type definitions from the module itself. If by some reason the library that we are using does not have its type definitions available in npm, we can always create our own type definitions. So let's say that, for example, Lodash did not have its type definitions available in npm, and we were installing it using the require statement of CommonJS. Let's go to the command line and we are going to remove the type definitions of Lodash from node modules @types. So with this we removed from @types the definitions of Lodash. We only left the definitions of the Node.js runtime. So now our program is compiling correctly, which is something that we might find surprising because let's have a look at what the type of this variable here is. This is of type any, but this is not an implicit any. If we hit Command or Control in Windows, we can hover over the require definition and we can click into it, and we jump straight into the definition where this value came from. So here we are inside @types, and this is the index of the types of the Node.js runtime. So you can see that the require import function is a function type of type nodeRequire. So if we hit Command and we click over it, we are going to jump into a definition that says that nodeRequire extends nodeRequire function. If we jump into this definition, we can see this function takes a string, so it takes a single parameter as a string. The parameter will be called ID, and the return type is any. So that explains this any type here. This comes from the type definition of the require function. And we're going to understand, take a look, this is a file named .d.ts. So this is a type definition file. We're going to understand what's the difference compared to plain TypeScript files. Let's create a similar type definition file for the Lodash library. So this is just an example. Usually we would simply use the standard type definition file. Let's create here a file called myLodash. And we're going to give it the extension .d.ts. So this is a type definition file. In here we are going to declare a type called Lodash, and we are going to say that for the moment Lodash is equivalent to the type any. Now let's go back to our program. we can now directly use the new Lodash type that we just created. As you can see, the auto-completion already shows it here. If we simply hit enter, we have now said that this variable here is of type Lodash. So if we hit command and we hover over the Lodash type definition and we click on our mouse, we are going to jump to our type definition file. Now what we want to do is we want to manually define the different functions that are part of Lodash, such as, for example, first. Let's start by declaring Lodash as an interface instead of a type. So this will list a series of functions that will be basically the Lodash API. Now, in order to declare the first function, we are going to declare another interface and we are going to call it first function. Now, we are declaring here a function type as we have seen before. So we are going to start by the arguments of the function. So in this case, we are going to define only one argument, which is an array of any, and the return type is of type any. So this is just an example of what the declaration of first could look like. Now we are going to use this function type that we have just defined to define a function named first. So first is of type first function. So if we now go back to our program and we remove the call to first here, if we hit Control space, we can see that first shows in the auto-completion list, and you can see the name of the parameter data, which is an array of any, and the return type is any. So with this we can autocomplete our program and we can pass it in the colors variable. So this is one way of adding types to an existing library that does not have them. We can declare them ourselves if needed. In the case of the Lodash library, we really want to use the types that are available via npm. So if you type npm install again, because the type dependencies had been saved here in dev dependencies, now our types are again installed under add types, and you can always confirm by opening the node modules project. So here we no longer need the Lodash type. The correct syntax to use for the remainder of the course will be import star as Lodash from Lodash. So if we click underscore here and hit Control space, we can see that all the type definitions are again available.